What if I told you that the constant search for a charger, the dreaded low battery warning, and the endless tangle of cables could soon become a thing of the past? Imagine a world where your phone, your smartwatch, or even your car could run for 50 years straight without ever needing to be plugged in. It sounds like something straight out of a science fiction movie, right? Well, get ready, because that future might be closer than you think, thanks to a groundbreaking innovation coming out of China. Researchers have just unveiled something truly revolutionary: a nuclear battery, no bigger than a coin, that can generate electricity continuously for half a century. No charging, no maintenance, just a steady, reliable stream of power. This isn't your typical power bank, it's a miniature power plant you can hold in your hand. So, how does this tiny marvel actually work? And what does it mean for the future of technology, energy, and our daily lives? Stick around, because we're about to dive deep into the science behind this incredible invention and explore how it could change everything. Let's break down the technology. This isn't a nuclear reactor like the ones that power cities, shrunk down to a microscopic size. The principle is actually much simpler and safer. The battery uses a technology called radioisotope decay. Inside this tiny device, there's a thin layer of a radioactive isotope, specifically nickel-63. As the atoms of nickel-63 naturally decay over time, they release energy in the form of particles. Surrounding this isotope layer are advanced diamond semiconductors. When the particles from the decaying isotope hit these semiconductors, they create an electric current. It's a process of directly converting nuclear energy into electrical energy. Think of it like a microscopic solar panel, but instead of capturing light from the sun, it captures energy from decaying atoms. And because this decay process is incredibly slow and steady, the battery can produce a consistent output of power for decades. Nickel-63 has a half-life of over 100 years, which is why the battery is projected to last for 50 years without any significant drop in performance. It's a clean, quiet, and incredibly efficient way to generate power on a small scale. There are no moving parts to wear out, no chemical reactions that degrade over time like in a lithium-ion battery, and absolutely no emissions. It's pure, solid-state power generation. Now, I know what some of you are thinking. The word nuclear can sound a bit scary. We immediately think of radiation and safety concerns. But the scientists behind this project have made safety their absolute top priority. The type of radiation emitted by nickel-63 is very low energy. In fact, it can't even penetrate a thin sheet of paper, let alone human skin. The battery itself is designed with multiple layers of shielding that completely contain all the radiation. The researchers have stated that the radiation levels outside the device are non-existent, making it perfectly safe for use in consumer electronics and even inside the human body for medical implants. So, you won't need a lead-lined case for your future smartphone. It's designed to be as safe, or even safer, than the batteries we use every single day. So, where could we see this technology being used? The possibilities are almost endless. Initially, the most obvious applications are in devices where changing a battery is difficult or impossible. Think of deep-sea sensors monitoring ocean conditions, remote weather stations in the Arctic, or satellites orbiting the Earth. For these, a 50-year power source is a complete game-changer, eliminating the need for costly and complex replacement missions. Then there's the medical field. Imagine pacemakers, cochlear implants, or internal glucose monitors that never need to be surgically replaced just to change a battery. This would dramatically improve the quality of life for millions of people, reducing the risks and costs associated with repeated surgeries. It could also power a new generation of smart implants that monitor health in real time and transmit data to doctors, all powered for a lifetime. But the truly exciting part is when this technology becomes mainstream and finds its way into our everyday gadgets. Imagine a smartphone that you buy and never have to charge. Ever. Or a laptop that runs for decades on a single internal power source. Drones that can stay airborne for months, revolutionizing delivery services and surveillance. Tiny, autonomous sensors could be scattered everywhere, creating a truly smart and interconnected world. From smart homes to smart cities, all running without the need for a power grid or constant battery replacements. The Internet of Things would finally have the perpetual power source it needs to reach its full potential. And what about bigger applications? While the current version of the battery produces a small amount of power, the technology is modular. The creators say that by stacking these batteries together, they can generate more power. Could this one day power electric vehicles? Imagine an EV that you never have to plug in. You'd buy it, and it would just run for its entire lifespan. That would completely eliminate range anxiety and the need for a massive charging infrastructure. It's a distant goal, but the fundamental technology makes it a theoretical possibility. This innovation isn't just about convenience, it's about a fundamental shift in how we think about energy. We currently live in a charge and deplete cycle. Our lives are dictated by battery percentages and the location of the nearest power outlet. This technology promises a future of set and forget power. This moves us away from our reliance on lithium-ion batteries, which have their own set of problems. The mining of lithium and cobalt is environmentally damaging and often involves ethical concerns. Furthermore, these batteries degrade over time and create a massive e-waste problem. A nuclear battery that lasts 50 years would drastically reduce the number of batteries we produce and discard, making our electronics far more sustainable. It's a form of clean energy that operates at the micro level, complementing larger-scale renewables like solar and wind. Of course, we're still in the early stages. The current prototype is a proof of concept, and there are hurdles to overcome before we see it in our iPhones. The main challenge right now is scaling up production and bringing the cost down. Manufacturing diamond semiconductors and handling radioactive isotopes is a complex and expensive process. The power output of the current single unit is also quite low, measured in microwatts, so significant engineering is needed to stack them effectively to power more demanding devices. However, the company behind it, Betavolt Technology, is confident. They've already entered the pilot testing phase and have ambitious plans to release a 1-watt battery by 2025. If they succeed, we could see the first commercial applications within just a few years. This development places China at the forefront of the global race for next-generation energy solutions. While research on similar beta-voltaic batteries has been happening in the US and Russia for years, this appears to be the first time a company has successfully miniaturized the technology and announced a clear path toward commercialization for consumer use. It is a testament to their focus on deep tech innovation and their ambition to lead the world in critical future technologies. So, what does this all mean for us? It means we are on the cusp of an energy revolution, a future where power is not a limited resource we constantly need to replenish, but an integrated, long-lasting component of the devices themselves. The era of charging cables and disposable batteries may be coming to an end. We are witnessing the birth of a technology that could redefine our relationship with our gadgets and reshape entire industries. The idea of a device that outlasts its own technological relevance, still holding its original charge, is a mind-bending concept. The coin-sized nuclear battery isn't just an engineering feat. It's a glimpse into a future powered by the atom, safely and silently, right in the palm of our hands. Thank you so much for watching and joining me on this exploration of what could be one of the most important inventions of our time. What do you think? What device would you want to have a 50-year battery in first? Let me know your thoughts down in the comments below. And if you enjoyed this video and want to stay updated on the latest tech breakthroughs that are shaping our future, make sure to hit that like button and subscribe to the channel. We'll see you in the next one.